still over exactly what I told you it was over. So it's over what the practice stuff was. But now we're going to pick up where we left off. So we did distance and midpoint. Let's do a quick refresher of that. Make sure we know what's going on there. So let's say we have point A is 6,2, point B is 7, -1, and we are going to find the distance and the midpoint. So here we go. Distance, how does that work? Who remembers? This is review from what we already did. Well, we have a lot of people absent here. Alec?
What's up?
Are you Alex?
I'm Alex.
And you're Alec?
Yeah, I'm Alex.
You're Alec. Okay, you guys are backwards here. Okay. All right. Leave you on your own to do the seating chart, and it comes out wrong. Okay, so you're Alec. All right, Alec, how's the distance formula work?
It's x minus x squared plus y minus y squared all over that.
So I'm going to subtract my x's, just like you said, x minus x. I'm going to subtract my y's, just like you said, y minus y. And then I'm going to do the arithmetic. So 6 minus 7 is -1 squared is 1. 2 minus -1 is 3 squared is 9. So the distance would be the square root of 10. Midpoint. How's that work? Braden?
So you would go, so it'd be -1 plus.
Wait a minute, Braden, are you in this class?
Yeah. I think I saw that yesterday. I think it's me.
Okay, all right. So how does midpoint work? Sorry.
So it's like, so it'd be like -1 plus 2, and then it'd be over 2, and then it'd be that one. That'd be the, and that one would be 6 plus 7 over 2.
Okay, and make sure you do this in the right order. We're looking for a point, so these have to be the x's and these have to be the y's. So really, it doesn't matter which order you do them in as long as you write the answer in the right spot. So if we do our x's first, thank you. If we do our x's first, then we'll have 6 plus 7 and 2 minus 1. So our midpoint will be 13 halves, 1 half. Is that all right with everybody?
Wait, why did you do plus there and then minus in the other one?
Because it's plus and negative.
Oh, okay, no.
I did plus both times, but one of them was a negative. Remember, midpoint is average. So you're always going to be adding and dividing by 2.
I went to the wrong class.
It happens.
Let me say that.
Okay, so who are you?
Went to the
Okay, see, my seating chart just has been blown all the heck. I can't learn your names when you keep moving around, people. So this is Quentin, and he's Charlie.
Yeah.
All right, and then who is that sitting in the middle back there?
Buddy.
Jake, buddy. Schmuddy.
You are Schmuddy, who was sitting.
By the wall.
All right, so now, Jake, that's your seat, okay? You stay there. All right, so then who are you?
Sam.
Sam who?
Trummel.
All right. And you are Alec.
Not Jim. Not Jim.
Okay. Okay, so now where Sam was is now Braden.
English.
You're far away.
Yeah, I was in the way.
Okay, I am missing
We have a quiz right after that stuff. Yeah, use the midpoint.
Okay, my head is ready to explode. All right, now, midpoint distance review, good. Anybody know what this is called? This is called the what?
Cartesian coordinate plane.
Good. Did we already talk about this?
Yeah.
Did we already identify the
Roman numerals.
all right. Roman numerals, yep, good. I thought we stopped with midpoint. All right, have we gone on to do problem
On the quiz.
in the book, page 20, number 19?
Yeah.
All right, that's our next task then. I'd like for everybody to look in your book on page 20. And if you don't have a book, take a picture of somebody's or peer over their shoulder. Page 20, problem 19.
Yeah, I will.
Do this in our notes.
Yeah, we're doing this problem together. It's got some good stuff in it. It says, find the area in the perimeter of the figure determined by the points -5, 3. So here's the point, -5, 3. Just for fun, I'm going to call that point C. I'm going to give it a name so we can talk about it. The book did not, but I'm going to. And then we have the point 0, -1. I'll call that point H. And then we have the point 4, 4. And I'll call that point S.
You said page 20.
Page 20, number 19. So the question gives me these 3 points, and it says, find the perimeter and the area of the figure formed by those 3 points. Now, obviously, those 3 points make a triangle. And we're going to find the perimeter and the area of the triangle. All right, let's start with perimeter. That's probably the easiest. How do we find perimeter? What's perimeter mean? All the sides added up, somebody said. Distance around. Oh, distance around. How do you think we're going to find the lengths of the sides? We're going to do the distance formula. So you guys over there on that side of the room, would you find CS for me? C to S? You guys in the middle, there aren't very many of you, but would you find CH? And you guys over here, would you do HS? We'll divide up the work. Everybody's doing the distance formula. Some of you are just using different points. Got your distance yet? What'd you guys get?
Square root of 41 for
Root
HS.
41 over here for HS. Anybody in agreement? Anybody else over here get root 41? Yep. Okay, we're gonna go with root 41. How about here in the middle? What'd you guys get? You got root 41? How about anybody else in the middle? Not done yet? How about you guys over here? Root 82, we're in agreement. Several of you said that, so that's good. In the middle there, let me know from C to H. Subtract your X's. So -5 minus 0. Subtract your Y's. I did get root 41. You guys in the middle get root 41? Okay, so our job was to find the perimeter. So we found all 3 sides now. So we're going to add them up. So that would be root 82 plus plus root 41 plus root 41. Now, actually, you can add these two together because they're the same radical. So if you have one root 41 and another root 41, you can add them together and make two root 41s. So your perimeter is root 82 plus 2 root 41s. There's nothing else you can do. That's where you stop. Root 82 plus 2 root 41s. Okay with that? Now, area, this is a little bit tricky. It's kind of disappointing they put a tricky one in this early. But it is. It's a little tricky. In Precal, one of the cool things about Precal, and there are many cool things, but one of the cool things is we're going to learn how to find the area of a triangle in 6 or 7 different ways. And some of them are really wonderful. But right now, you only have one way of finding the area of a triangle. How is that?
1/2 base times height.
1/2 base times height. So you need, in that triangle right there, you need a base and a height. Now, what's the relationship between the base and the height of a triangle? They are perpendicular to each other. So we need to find something in this problem that's perpendicular so that I have a base and a height. I can't just say, okay, this is the base and this is the height. I need to know I have a right angle somewhere, right? Now, if you can trust my picture, which you usually can't, if there's a right angle in here, it looks like it's here, right? More than here. Looks like it's that one probably. So I'm going to test it to see if it is. My picture looks like that's a right angle. And if it is, then that could be the base and that could be the height, or vice versa. And I'm ready to go. But I don't know that that's a right angle. So I've got to figure out if that's a right angle. How do I do that? Do you have any thoughts on that? How can I tell if these two lines are perpendicular to each other?
If they have, isn't like opposite and equal slope, or just opposite slope?
Opposite
Reciprocal
slopes. So one way, and we haven't talked about this yet, you and I, but you did it last year. One way that you can tell if lines are perpendicular is to check their slope. Okay, now we gotta remember how to do that. If that's what we're gonna do, we have to remember how to do it. Does anybody remember how to find the slope, let's say, of CH? M is slope, if that helps you get started. Remember how to find M, the slope. Abby? You are very close. Y over X, that's right. So it's Y minus Y over X minus X. Remember, rise over run? Rise is up and down is Y. So rise over run means Y over X. Okay, so here we go. 3 minus -1 over -5 minus 0. Y minus Y, just like Abby said, Y minus Y, X minus X. That works out to be 4 over -5. Now that's for CH. I'm hoping these two are perpendicular. So if this one has a slope of -4/5, what am I hoping this one is? 5/4. Let's check it out and see. This is HS. So the slope of HS will be Y minus Y over X minus X. So I did 4 minus -1 over 4 minus 0. And sure enough, that's 5/4. Which means these two lines are perpendicular to each other. So I have my base and my height. And why did I need my base and my height? Because I'm supposed to be finding the the area will be 1/2 my base, which is root 41, times my height, which is also root 41. One of these is the base and one of them's the height. It doesn't matter which is which. So what's root 41 times root 41? 41. So my answer is 41/2, or whatever decimal, 20.5. Now, what if those hadn't been perpendicular? Then we have a whole different problem that we're not ready for yet. Anybody have a different thought on finding out if that was a right angle? This is beautiful. This is beautiful. It will work every time. So if that's how you think and you're comfortable, that's great. Stop right there. Does anybody have a different thought? There's always more than one way to do it. Anybody have a different thought? This side was root 41, and this side was root 41, and this side was root 82. Remember something called a squared plus b squared equals c squared? What is that? Pythagorean theorem. And the Pythagorean theorem only works in triangles that are, right, 90 degrees. So if we did root 41 squared plus root 41 squared, do we get root 82 squared? We do. If the Pythagorean theorem works, the triangle is a right triangle, and therefore you have a right angle. So that's just a different option for you. Don't do both of these things, but you needed to find a right angle. You can do it either way. You okay with that? All right. Now, oh, I don't want to keep you too late for lunch. When are we supposed to go to lunch here? Not for a while. Okay. All right. Okay. All right, next. Does anybody know what this is? Anybody know what that is? You should. Think back in your memory. It's not a line, right? What do lines look like? Y equals mx plus b, that's what lines look like. Somebody said parabola. Actually, you're in the right ballpark, but it's not a parabola either. Parabolas only have one squared term, so it wouldn't be x squared and y squared. It would be a plain y and an x squared, or vice versa. If both of these are squared, this one is a circle. It could be an ellipse or hyperbola. We'll get there soon enough. This is a circle, okay? An x squared plus a y squared is going to be a circle. Your job is to tell me the center and the radius of this circle. The center and the radius. Somebody back there remembers. What did you say? No, you said it right. Go ahead and say it again. It is 2, -3. The center of the circle is 2, -3. The center of the circle is 2, -3. Do you see where she got those points? And she is Sophie. Good job, Sophie. Opposite of these parentheses is where your center is. Anybody remember what the radius is? Morgan?
Root 19.
Root 19. Right on target. Very, very good. Where did that come from? It's the square root of that number. Don't tell me you didn't do that last year, because I know you did. Let's try another one. I'm gonna try to trick you here. What's the center here? 0, -7. Very good. And what's my radius? 9. Could you go the other way? If I said to you, write the equation of the circle. If the center is -3, -4, and the radius is 5, could you come up with an equation that looked like this? What would it be? X plus 3 squared, very good. Y plus 4 squared, very good, equals 25. Are you okay with that? Everybody thinks this is great. You're sitting there thinking, Precal is so dang easy. All right, let's try this. Write the equation of the circle whose diameter has endpoints at 3, -4 and 7, 10. Now wait a minute. Up here, just a second ago, I said write the equation circle, and we did that. It was easy. What information did we have to make this easy? What were you given? The center, that's how you did this part, right? And then you also knew the radius. So if I'm gonna write the equation of a circle, I need to know the center and the radius. I did not give you the center and the radius. What I gave you were the endpoints of a diameter. So what are you going to do to write the equation of the circle, Miss Maya?
You need to find the distance.
We need to find the distance from what to what?
The endpoints.
And do what with that?
And then
Cut it in half. So she's saying I need the radius. And to get the radius, I can find the diameter and cut it in half. All right, so let's go ahead and do that. So the diameter, and I'm going to write diameter here so we know. The diameter would be, okay, how does this work again, distance formula? Three minus 7. So I subtract my x's, so 3 minus 7, and square that. And -4 minus 10, oh shoot, this is going to be a big number, and square that. So I end up with, okay, 3 minus 7, -4 squared, 16. -4 minus 10, -14, is that 196?
Yeah.
So adding that up gives me 212. Square root of 212. Now that's the diameter. So we need to cut that in half. When you cut it in half, kids, you can't just divide 212 by 2. Do you understand that? You have to simplify this radical. So 212 is 2 times 106, which is 2 times 53. So my diameter is 2 root 53. Did I pull a fast one there? Did you keep up? That's my diameter. So what's my radius, which is what we really needed from the beginning? What's my radius? Just root 53. So whatever equation I write here, if the radius is root 53, then what's this going to equal over here? 53. All right, so far so good. Good job. What am I missing? I'm missing the center, which, as you just said, Chandler, is the midpoint. So let's review that. How do we find midpoint? What do we do? Average our x's. So 3 plus 7 is 10, divided by 2 is 5. Negative 4 plus 10 is 6, divided by 2 is 3. Then I can write my equation. X minus 5 squared, y minus 3 squared equals 53. Now, I'm going to just step aside for a second and say, math is wonderful because you can always do the problem more than one way. Had I been left alone to do this problem, or if I was sitting in here all by myself and I were going to do this problem, I would have done it in the other order. I would have found the midpoint first, and then I would have found my radius going from here to here. And what that does for me is it saves me the hassle of reducing the radical so that I can divide it by 2. I can't divide that radical by 2 until I reduce it, right? If I don't deal with the diameter, if I just go straight to the radius, then I don't have to do that. Does it matter in the end? Nope, I get the same answer both ways. That's why we like math. Okay, one more thing to talk about. Oh, I don't know if I'll get this done or not. We may have to finish this later. Any questions about this before I erase it? Everybody followed everything? You're good? That's a GTQ, guaranteed test question. So I'm going to give you 2 points and say these are the endpoints of a diameter. Write the equation of a circle. You know that to write the equation of a circle, you need the center and the radius. To get the center, you'll use midpoint. To get the radius, you'll use distance formula, and you'll put it all together and get your answer. Okay. Now I'm going to ask you to think differently than you probably ever have before about this certain topic. I'm going to ask you to think like a calculus student. Here's what I'm going to ask you to think about. Here's my number line, here's 11, and here's 17. If I said to you, what is the distance between 11 and 17, you would say 6, and you would have gotten that 6 by doing what? Subtracting. So most of you probably did 17 minus 11. This all happened in your head. You just did it fast, you know, it's automatic. But you might have, somebody might have subtracted 11 minus 17, which is perfectly okay as long as you make it positive, right? If we're talking about distance. And to make something positive, to just artificially make it positive, we take the absolute value of it. Doesn't that just make whatever it is positive? So when I look at this right here, this basically is saying the distance between 11 and 17. Either one of these. That's what it's saying. The distance between 11 and 17. So when I look in my book and I see a problem like this, I'm thinking, okay, that means the distance between some number and 3. And then when they stick on something like this, I think, wait a minute, the distance between some number and 3 has to be less than 4. So here's my number line, and there's 3. Now this says the distance between some number and 3 has to be less than 4. So what's the furthest out this way that number could be? If the distance has to be less than 4, the furthest out it could be would be 7, right? Does that make sense to you? Can it be 7? No, because then the distance would be 4, but it can be everything up to 7. What about the other direction? What would the lower boundary be?
-1.
-1. Those 2 points are exactly 4 units away from 3, but I want to be less than 4 units. Where's that? Everything in between them. Very good. So the answer to that question in interval notation would be negative parentheses, -1, 7, parentheses. Those are the numbers that are less than 4 units away from 3. Now some of you are thinking, oh my gosh, that's hard. No, it's really not. Let's try another one. This will be the last one, then you go to lunch, okay? What does this say right here? What is this? The distance between some number and 2 has to be more than 6. Okay? So here's 2. Some number could be over here or over here. The distance between some number and 2 is more than 6. So what's this boundary? 8. What's this one? -4. This time, I'm going to close those boundaries in. Would you agree? Last time, we shaded between the 2 numbers. Because last time, we wanted the distance to be less than 4. Now I want the distance to be greater than 6. So what am I going to do? Out here and out here. So in interval notation, parentheses, -infinity to -4 bracket. Remember, your infinities are always open, always parentheses. Or union, bracket 8, infinity. We'll practice a few more when you get back. After we take our physics, which will only take a few minutes. All right, now let me tell you when I want you back.